Hello, and welcome to another episode of Constructed by Example. In this episode, I will be showing you how to create a police chase car game, which is procedurally generated. You can see here the end result, in which the roads are procedurally generated, and there are oil stains on the road which you have to avoid, and every so now and then you get another car on the road, which you have to avoid, and which the police car also tries to avoid. Sometimes he lags a bit behind, but he tries to catch you anyways, and if you screw up, he catches you, and the game is over. So how to create this? Well, this is the main game layout. It consists out of a number of layers. The roads layer is where all of the roads are spawned. This is the bottom layer. Only the first few tracks of the roads have been put on the layout. These 5 tracks here, or 6 tracks, a few tracks. All other tracks are procedurally generated where the car moves. The same applies for the scenery. Scenery is already placed alongside the road, but for scenery, for the grass tiles, the trees and the rocks, they are on a dedicated layer. This layer here. Cars move along the way using waypoints. They are created when the roads are created, but they have a separate layer. Obstacles can be placed on the road, and the current version of the game only supports oil stains, but the game can easily be extended with some other obstacles as well. And obstacles have their own layer as well. If you want to see a waypoint, the waypoints are the yellow markers here at the top. Cars can be spawned on their own layer as well. This counts for the user car, being the car being driven by the user, the police car, and the chasing car. This counts for the user car, being the car driven by the user, the police car chasing the user, and the other cars that are just cruising around, making it difficult to get by. The marker layer only contains the marker in the middle of the screen. This marker is important. Let me just show you the marker layer. This is one here. So this marker is important because it is a reference point used by the procedural generation of the roads, actually, so it's important. Finally, the dialog layer contains every object type used in the dialog, and the HUD layer contains the text on the top of the screen. Both the HUD and the dialog layer all have parallax rate 0x0 and scale rate 0, which is set here. Here you can see the text on the dialog and the retry button. The user car is the blue car in the middle, which has gotten the scroll to behavior because the screen would go along with the car while we're driving. Next to that, that has got the car behavior, which has pretty much all of the default settings except for the maximum speed, which is set inside the code, because it depends if the user is driving on tarmac, on grass, or on oil. These are 2 particle effects, one of the mud and one of oil, which are pinned to the car at runtime. You can find them here. They're only spraying when the car drives in the grass or in the oil. The image is pretty simple, and the spray cone has been set to 45 degrees, so it seems that the car is skidding in the mud or in oil. So very simple sprite here. The police car has some other logic to it. It has the car behavior as well. Let's check it out. It has the car behavior as well, but pretty much the same default settings except for the max speed and the default controls. The max speed is set to a fraction slower than the max speed of the user, so it is possible to escape from it if you drive well. Next to that, there is the tween behavior, which is used to smoothly take its turns towards the next waypoint. The line of sight takes care of some more AI. It is used to detect the car when it goes close by and chase after it when it goes off-road. And it also detects other cars and moves to another lane when the car is driving in its own lane. For that, the position instance variable is used. Timer object at the top of the screen is hidden for the user and serves its only purpose by continuously checking if it needs to spawn another car. Roads, other cars and scenery items have all been placed in their respective families because they share the same behavior amongst each other. Scenery holds a reference to the title they are spawned on. That way, scenery can be destroyed along with the tile if needed. They also have the solid behavior so cars can bump into them. Roads only have a counter instance variable. It's just a counter that gets increased time every time a road is spawned. Click a road, the counter instance variable. Well, it's just a counter that gets increased every time a road is spawned. So the AI cars can drive from road piece to road piece using its waypoints with the same counter. Other cars are somewhat more complicated. They also have the car behavior but pretty much the same defaults, except they have lots and lots slower speed. Let's go look at the other cars. Slower speeds. They don't have default controls. Because they are controlled by the code, and they have the same tween behavior to be able to take their turns smoothly, and they have the solid behavior so cars can bump into them. Other cars use the next waypoint and position instance variables to steer around the roads, and the has been on screen instance variable is involved in destroying the cars when they are no longer needed. Waypoints only hold two instance variables: the counter and the position. This counter is the numbered link to the road piece they are on, and the position tells us if the waypoint is on the left or on the right lane. You can see that there. Alright, let's look a bit at the code. So there are a number of variables used inside the code, and there is an include to an event sheet called probability tables. And if we go and look inside that event sheet, you can see there are a number of probability tables being created using the advanced random plugin. So every road piece, as you can see here at the right hand side, has its own codification. HL stands for horizontal left, again another one horizontal right. We have two of the same here because it's a different logic when a car is driving to the left or to the right horizontally. A road going from the left up, going from the right up, from up to left, from up to right, and vertical. Depending on all of these, the next tile is either can be either vertical or horizontal or right up and upright and stuff like that, depending on the current the last road being generated basically. So when this road was last generated, the next one, 3 out of 1 will be this one, and 1 out of 3 out of 4 will be this, and 1 out of 4 will be this one. That's what it means actually. So for this road, these are the odds of the next road being spawned. If the current the last road was this one, these are the odds of a road being spawned, and so on. Also for the scenery, we make entries, 3 large, 3 small, rock 1, rock 2, rock 3, etc. are all on the scenery table. There's also a none entry set to 25, so it wouldn't generate too much scenery actually. And then there's other car, which holds the 3 other possible cars. Let's see the 3 other possible cars that can be spawned in the game. So next, let's look at the game code. So this is the initialization part. On start of layout, first we're going to make sure that the dialog with the retry button is hidden. We just do that by calling a function hide dialog. We come back to that later. And then we reset the number of variables. Chase is a variable that becomes 1 if the police car is close enough to the user car and starts chasing it around instead of using waypoints. The current road is the road we're currently handling. And the horizontal offset is the offset of the road generation to the left or to the right. Vertical offset is very important, as the vertical which actually start generating from a certain vertical offset towards the center point, towards the center marker which I showed you. So the center marker is set at offset 0, and the top road, excuse me, on the layout, so this one here, has got count 5, but from the marker, excuse me, here in the middle, this is -1, -2, -3, -4. So starting from -4, we need to go up, and start adding more roads. So that's why vertical offset is defaulted to the -5, -4, excuse me. And then the generation counter, it's a counter that goes up. Right now the top road has counter 5, so every time a road gets spawned, the generation counter will go up, and that road will get that generation counter. So then there is a spawn distance, from which distance beyond the layout there will be need for roads to be generated. So this is called the spawn distance, and by default it's set to times the tile size times 6, and tile size is like a constant here above. So if you were to generate roads, only if a car gets to the last road, the user car gets to the last road, you would see the spawning of roads happening on the screen every time. And that's a bit sloppy. That's why we prefer to have spawning distance. That means if a car becomes too close to an area where there are no roads being spawned, the roads will start being spawned whenever it's only 6 tiles away. So it actually always spawns tiles 6 tiles in the future, past the layout. And then we set the last spawned road to a vertical road, because that's just the vertical road is what's being placed on the layout, and we can use it later. We spawn the user car at the X and Y marker, and we initialize the probability tables. And then we give the user car a head start by waiting 1 second. And we start the police car chase on its hunt for the next waypoint, actually. So once it arrives at the next waypoint, this function will be called again, searching for the next waypoint, and the angle of the police car will always be set in the angle of the correct waypoint. So a little bit of setup here. We add the mud particles and the oil particles to the tile, and we initialize the line of sight of the police car so it can detect user cars and other cars. That's basically it for initialization. So for base functionality, what we'll do on every tick, we automate the police car and the other cars by virtually accelerating the car constantly. So on every tick we simulate the car pressing accelerate. And also we update the HUD continuously. And then all the code here is actually in order to spawn extra roads, and it happens on every tick because we constantly need to be checking on the spawn distance. If the car is moving along, if it's not within the distance of 6 tiles, which is the spawn distance of 6 tiles towards the user car, because if the user car arrives at that point or beyond that point, new tiles will have to be spawned, new rows will have to be spawned. So the marker in the center of the layout serves as a starting point. The vertical and horizontal offset is the number of tiles the currently spawned road is away from the marker at the X or Y axis. For us to determine the vertical distance, we do that by calculating dy for delta y. We do it here. The spawn distance is set on initialization of the layout and is expressed as 6 tiles. We showed you that earlier. The current vertical offset is to be considered as the distance in the layout beyond the distance beyond the layout that the road was last spawned. If it's not far enough away, spawn the next road, because we need to keep on generating tracks to drive on. So that's essentially what I told you already. First, determine the next piece of road to be driven on. So we set the probability table correctly, and the name of the probability table is the name of the road that was last spawned. The entries in the probability table are related to the last spawned road because the next road needs to make sense in the context of the previous road. So we set the advanced random's current probability table to the last spawned road, and we determine the next row. So road to spawn will be the next road. We set the last spawned road for the next iteration, and effectively create the road at the correct X and Y coordinates, taking into account the horizontal and the vertical offset. So that's what we do here. Yeah? So we start from the marker X, we add the horizontal offset times tile size, so we go up in the X axis, we go up in the X right, and the horizontal offset, which can be positive or negative. And we add to the Y marker the vertical offset, which is a negative number tiles times size. And then, depending on the last spawned road, which we set here, and the road is vertical, so we increase the vertical offset. If it's horizontal, we increase the horizontal offset, etc., depending on the road we are using. So next, we pick the last created road. We use the generation counter variable to keep track on how many road pieces were already generated. We use it to set the counter of the road as well as the waypoints. The AI cars go from waypoint to waypoint in ascending order of the counter. So we increase the generation counter and we set the roads counter to that generation counter. And then we generate 2 waypoints, one at the left side and one at the right side of the lane. And we also just set the generation counter. The position determines left or right. We set it invisible, of course, and we set its width to 50, which is about good to always have some overlapping with the user with an AI car actually. So in this section below, the grass tiles and the scenery object are spawned next to the road. So depending on which road we have spawned, we will call the spawn grass tile with other X and Y coordinates to be able to spawn things at the correct place. If a road was created on top of a grass tile that was already generated in one of the prior iterations, we need to remove it. So that can be happening, for example, if a road goes to the right and a few minutes later it goes immediately again to the left. The horizontal road pieces will have spawned scenery above and beyond, above and below the roads, and then if the procedural generation decides that the road will be turning back in the opposite direction, it actually encounters one of the scenery items. So, and this is what the code will do. Pick the grass tile where the road is supposed to be, and destroy the grass tile, destroy the grass tile, and along with the scenery on it. So every once in a while, some oil is generated as an obstacle. So we do it with the random generator. The X and Y positions also get randomized, so it looks a bit more organical. But if the chase variable is 1, and we will see later where this is set, the angle of the police car is set towards the angle of the user car, so it actually starts chasing it instead of following the waypoints. So next we do some cleanup and clean up the roads that are far enough away, depending on the X and Y coordinates of the user car. Also clean up the scenery, the grass tiles, the waypoints. And when the user car goes far enough away from the police car, we consider the game as 1 and show the dialogue with 1 as a success parameter. So if the absolute distance between the car and the police car is more than 1000. When the police car collides with the user car, the game is also over and we show the dialogue success 0. So in the AI section, there is a function police car aim for next waypoint. So it's called once in a while. And what we do is we pick the waypoint by its counter, which is passed as a parameter, and rotate smoothly towards the correct angle using the tween behavior. So we're using that waypoint 1, 2, 3, for example, position left side of the road. We pick the waypoint at that position and we rotate the police car with that angle. The same actually happens for the user car. We pick the user car with the UID passed as a parameter, and then we do the same thing. And then we increase the next waypoint in the other cars to go to the next waypoint. So when the police car is overlapping a waypoint and is not chasing a user car, we go to the next waypoint. So we when we overlapping and not chasing, we call that same function to go to the next waypoint. We also use trigger once here because otherwise it is called every time constantly when a police car is overlapping a certain waypoint, which is way too much. It only should happen once per waypoint, so that's why the trigger once condition is in here. When the car is overlapping a waypoint, another car is overlapping a waypoint, we set its waypoint and we call the other car's aim for next waypoint function I explained earlier. It's very simple. When the user is overlapping grass, we need to decrease the speed a bit and spray some mud. That's what's happening here. We only do that if the car speed is more than 10, because if it stops on a grass tile, for example, it doesn't need spraying mud particles. That's what I do here. Same thing for oil. And then if it's not overlapping grass or oil, we just set it to the normal speed and we stop spraying mud and mud particles. So here we add some extra AI by starting a chase from the user car when it is in sight. This sets the chase flag to 1. And when chasing, the police car, it doesn't follow the waypoints, but instead it directs its angle towards the user car, so it's harder for the user to avoid the police actually. If the police car sees another car, it looks at the lane the other car is driving on and changes the position of the police car next time it passes over that waypoint. The game can start spawning other cars once it has passed the timer object. Avoid starting too many timers by using the timer trigger once functionality. So when the timer spawner is done and the car is actually driving a decent speed and there are 3 or less cars generated at the moment, we spawn a user car. So we do that in first place not to have too many cars on the road, and also if the user car is standing still, it doesn't keep on spawning the same user cars a bit further down the road on top of each other. That's actually to avoid that. Keep track of the road the user is driving on, so other cars can be spawned in respect to that location. That's what I'm doing. So I'm doing here. So every time a user car is overlapping a road, the current road is set to that road, always augmenting. When the other car is on the screen and it has been on the screen, we set a flag, and then if it's no longer on the screen and it has been on the screen and the distance is far enough from the user car, we just destroy it. And if we're overlapping yeah, this is a little bit of a hack. Sometimes a user car gets a bit astray and it goes and overlaps a grass tile, just drives down the dirt road. In that case, we just destroy the other car. So that's it for the AI. Let's go for the spawning. Spawn grass tile is the function that spawns a grass tile at a certain x and y coordinate. But first we need to check if the grass we are spawning is not overlapping a row that was spawned earlier. So if picking action succeeds, that means that there is a road and the grass tile is not to be spawned actually. Then we spawn the grass tile itself on the x and y coordinates, and we populate it with some random scenery using the spawn random scenery function, which is this one here. So first we pick the grass tile, which is passed as a parameter, and select the correct probability table. So we generate up to 10 scenery items on the grass tile. The grass tiles have 10 image points, each of which can be assigned a scenery item. The weighted expression of the advanced random plugin is used to get a random scenery item here. Only if the scenery item is none, we need to do something. Having a greater chance of having no scenery avoids overcrowding the grass tiles. Finally, create a scenery around the image point. Here we use that using the image point x and image point y functions of sprite. We pick the last created scenery, we rotate it by some random degrees, and we assign a UID of the grass tile to reference to a reference instance variable, so that the screen item can be deleted together with the grass if we needed to. And here we just make sure that trees are generated above rocks and not vice versa, because otherwise it would look not so nice. And then there's a spawn other car. We get a road UID passed as a parameter. We set the correct probability table first. So the given parameter is the UID of a road piece where the cars started driving on. We pick that road piece and we set the counter to that road piece. Using the retained counter, we pick the road with 6 pieces further down the road. Yeah? We pick a random car type. So we pick the last generated car. We set it to go straight ahead and set the next waypoint to the counter of the road if it's spawned on actually. We set the lane left or right and steer the car on its way using the other car's aim for next waypoint function. So that's it. Finally, there's some dialog logic where we show the dialog and hide the dialog, and we set it the layer visible and activate or deactivate the logic. And we actually disable and enable the cars so the cars stop. So that's it. Thank you for watching. As always, please like and subscribe. I will leave a link to the Sura store in the description of the video if you would like to get the complete template for this game.